Today we will see three-dimensional geometry and few topics in that. So first is direction cosines and direction ratio. So as the name says, we have three dimensions. So I have taken x-axis, y-axis and z-axis. Now let's say we have a point P with coordinates x, y, z in the axis. So P will obviously have these coordinates as it is lying in three-dimensional space. So now this OP, so OP is the position vector of P. Now let's say it is making angle alpha with positive direction of x-axis, and it is making, and this vector OP is making angle beta with the positive direction of y-axis, and also here this OP is making angle gamma with the positive direction of z-axis. So then these alpha, beta and gamma, they are called direction angles. Then the cosine of these direction angles are known as the direction cosines. So when you will find out the cos alpha, means you'll take the cos of all these angles, so cos alpha, cos beta and cos gamma. So only this is known as direction cosines. So direction cosines are simply the cosines of the direction angles. You will increase this line to some other point P1 as well, then the coordinates will change. These x coordinate will change, x, y, z coordinates will change, but the direction cosine will remain always the same because the angles are already alpha, beta and gamma. So the direction will remain always same, but still the position will change. So because of that, the length of this vector or OP1 will change, but still direction cosines will be same in this case. Now if the points are given, like in this question, we have already P is given x, y, z. So in this case, when you have only the points, so that time you can find out these direction cosines. So these direction cosines will be simply cos alpha equals to the x coordinate divided by root of x square plus y square plus z square. So that will give you the cos alpha, and this is also known as L. We can also represent this thing as L. So cos beta will be y divided by root of x square plus y square plus z square, and also that is can be written as M. So these L, M, N or cos alpha, cos beta, cos gamma are the direction cosines. So we have discussed the direction cosines. Now I'll tell you what exactly direction ratios are. So direction ratios are any number proportional to the direction cosines. It is known as direction ratio of a line, and these direction numbers are represented by A, B and C, and in my case it will be X, Y and Z. So here also you can see, if you find out the X, then X will be how much? It will be L into this whole thing. So X will be like L into root over x square plus y square plus z square. So this value can be anything. So you can say that this direction ratio will be, if we will assume this x square plus y square as plus z square as k, so you can write x as lk and y as mk and z as nk. So all these x, y and z are proportional to L, M, N, and these x, y, z are the direction ratios. Now let's see the relationship between the direction cosines of the line. So as you know that direction cosines are L, M and N. So there is a relation between these three. So L square plus M square plus N square is always 1. Or you can also say cos square beta alpha plus cos square beta plus cos square gamma will always be equals to 1. So that you have to remember all the time. So sometimes you will get questions based on this also, like two angles will be given and you need to find out the third angle sometimes. So this relation is very important for that case. To make it more clear, I have taken an example. If the line has a direction ratio, so here the ratios are given -18, 12 and -4. These are the direction ratios. So you can simply say DRs. So DRs are given this, and you have to find out the DCs. So here, as I told, it's very easy to find out. So here this is A, this is B, and this is C. So first we will find out the R. You can say R. So that is your A square plus B square plus C square. That would be minus 18 square, 12 square. Still you'll get plus only. I'm taking this one. So here if you solve it, to solve it, you can take common also. You can take 4 common from all. So whole thing will give you 22. So now we have to find out the DC. So as I told, that cos alpha will be how much? X divided by root over, or here we have taken A. So it will be A divided by root over A square plus B square plus C square, or A by R. So here that will be your L. So L will be how much? A is minus 18 and this is 22. The same way your M, you can simplify it. That side will be 9 by 11 and then M will be 12 by 22. So that will be 6 by 11. And the same way you can find out N as well. So N will be minus 4 divided by 22 minus 2 by 11. So that only you will get. Now in this you will also get that kind of questions where 2 points will be given and you have to find the direction cosines or direction ratios of the line passing through 2 points. So let's say we have a point P having the coordinates A1, B1, C1, and the coordinates of Q are A2, B2, C2. So now you have to find out the direction ratios of PQ. So first I'll find out the direction ratios of PQ. So if you have to find out the direction ratios of PQ, so simply for DRs of PQ, for the x coordinate, here you will write x coordinate of Q minus x coordinate of x of P. Okay, so this will give you the direction cosines for this. This I'm making like this. So that will give you the same thing. If you want the y, so y will be y of Q minus y of P. The same thing for z. So z of, so here we'll write z of Q minus z of P. So that will give you the DRs. So here the DR will be A2 minus A1 comma B2 minus B1 divided by C2 minus C1. So like this you can find out, and then you can find out these are the DRs. So whenever you have the DRs, you can easily find the DCs as well. So DCs will be easy. So here these are the DRs, and DCs you know how to find out. So for finding the DCs, it will be A2 minus A1 divided by root over A2 minus A1 whole square plus B2 minus B1 whole square plus C2 minus C1 whole square. This whole thing I have to write here, and that will give you the L. The same way to find out M, it will be B2 minus B1 divided by this whole thing, and then for N it will be C2 minus C1 divided by root of A2 minus A1 square plus B2 minus B1 square plus C2 minus C1. That will be the DCs. Let's see it with the example. So here we have to find out the direction cosines of the sides of the triangle whose vertex are given. So I'll just show you the direction cosines of AB only, and then BC and CA you can only easily find out. So DRs of AB will be, so as I told, it will be x of B minus x of A. That will give you the A, and the same way y of B minus y of A. Same thing you will do for Z. So simply writing it. So here you can see that will be minus 1 comma minus 1 minus 3 will give you the first, and then second will be 1 minus 5, that is 1 minus 5, and then the next one will be 2 minus of minus 4, so that will be plus 4. So the direction cosine will be minus 4 minus 4. Here we will have 6. So these are the DRs of AB, Then you have to find out the DCs of AB. So it will be minus 4 divided by root over minus 4 square plus minus 4 square plus 6 square. And then same thing, minus 4 divided by whole this thing, minus 4 square plus 6 square, then 6 divided by the same thing. So it will solve it. So that will be minus 4 by 2 root 17 minus 4 by 2 root 17 comma 6 by 2 root 17, and you can just little bit simplify, so that can be written as minus 2 by 17 minus 2 by 17, then 3 by root 17, and this way you can find out the direction ratios of and DCs of BC and CA as well. Sometimes you will get the questions like you have to prove that 3 points are collinear. So in that case, you will find out, like you will find out the DRs of AB and DRs of BC. So you will see that the DRs of AB and BC will be proportional. So in that case, you can prove that the 3 points are collinear also.